Everyone, and welcome to ITLS Academy Empower the Youth. So today in this lecture we will going to study about atomic absorption spectroscopy. So in this particular lecture we will going to cover the principal part. We will going to cover the instrumentation of atomic absorption spectroscopy. We will going to discuss about all the component of the instrument detail, and we will also see some important questions related to atomic absorption spectroscopy. So now let's get started with the first heading, that is what is atomic absorption spectroscopy. So in short you can say AAS, that is atomic absorption spectroscopy. So the atomic absorption spectroscopy, it is an instrumental analysis technique for a rapid trace metal analysis. So it is based on the element specific wavelength absorption by ground state atoms in the flame or electrothermal graphite furnace. So what does this atomic absorption spectroscopy is? So it is nothing but it is an instrumental analysis technique wherever you want to have a rapid trace of metal analysis, where you want to analyze the metal in a very fast manner. So this technique is used. So it is based on the on in exams also they can ask you on which principle it is based on. So it is based on the element specific wavelength light absorption, okay, by the ground state atoms in the flame or the electrothermal graphite furnace. So the ground atom, the atom that is present in the ground state, so they are present in a flame or electrothermal graphite furnace. So atomic absorption spectroscopy provide us with the data of absorbance of electromagnetic radiation by specific elements. So atomic absorption spectroscopy, it provides the data of the absorbance of electromagnetic radiation, means how the electromagnetic radiation is taking place by a specific element. So let's say this is a element, this is a element, okay, E for element. So this element, how much electromagnetic radiation this element is absorbing, okay. So this atomic absorption give the data of that, give the data of how much this element is absorbing the electromagnetic radiation, okay. So this technique is widely used to determine the presence of unknown elements like alkali or alkali earth material in the sample. So this technique is very important where you want to know the unknown element, okay. So in the previous technique, that technique is not very much useful in determining the unknown element, but this atomic absorption spectroscopy, it is very important whenever you want to I want to determine the presence of unknown element, for example alkali or alkali earth metals in the sample. So in a sample, if there is a alkali or alkali earth metal, so this technique is very much important in determining those elements, okay. It finds the immense application in the analysis for the trace metal in solid, lake, river, ocean and drinking water, pharmaceuticals, foods and beverages, geological, mineralogical sample, petroleum products, biological fluids, specimen forensic analysis. So it is a common to get a result in ppm level and higher sensitivity of ppb level when ppm level using a graphite furnace atomization atomization. So this technique, it is very much important. As you can see, I have mentioned different fields like in soil, river, drinking water, pharmaceutical, beverages. So as you can see that this application, this technique is having the application in each of the field, whether it's a soil, whether it's a marine life, whether it's a pharmaceutical, whether it's a food or a beverage, Even in the geographical study also, this technique is very important whenever you want to determine the analysis of the minerals that is present in the sample. So this technique is used in petroleum product. So it has a very vast application as in different industries. Even in the forensic analysis also, this technique is very important. So the one question generally arises that this technique gives the result in the ppm level. Okay, and whenever you are taking a higher sensitivity of ppb level, so when we using graphite furnace atomization, so this technique is very important in every field of industries, and it gives the result in the ppm level. Okay, so this is the introduction, or you can say the what is absorption spectroscopy. Now let's quickly understand what is the history behind this atomic absorption spectroscopy. So who are the scientists, who are the persons? So these are the three persons. I'm just naming them one by one. So they have contributed their study in the discovery of this atomic absorption spectroscopy. Okay, so the earliest spectroscopy was first determined by Marci von Kronland in 1968. So he is the scientist. As you can see the first image, so he is the scientist known as Marcellus Emery, and he was the first person in 1964 by which he analyzed the sunlight as it passed through water droplet and thus creating a rainbow. So Marcy von Kronland was the first person in year 1964. He analyzed, so he analyzed how the sunlight, means how the ray of the sunlight it passes through the water droplet, and after passing through a water droplet it create a rainbow that we already have seen many times in the sky after the rain, after in the rainy season mostly. So further analysis of the sunlight by the William Hyde Woolston led to the discovery of black lines in the spectrum, which is in 1820. Okay, so the second is William Hyde. So he recognized or analyzed the sunlight. Okay, further sunlight को इन्होंने analyze किया, and he gives the discovery of the black lines that is present in the spectrum. Have you ever seen the spectrum? So the black lines and the discovery of that black lines in the spectrum was given by the William Hyde Holston. Okay. Then comes the third person, that is Sir David Brewster. He explained as how absorption of light in the sun's atmosphere, means how the light is absorbed in the sun's atmosphere. So three are the scientists is here. So they gave the different contribution in the atomic absorption spectroscopy. The first one is Marcus Marcy. He recognized how the sunlight is passing through the water droplet and thus creating a rainbow. Further, second was William Hyde. He gives the analysis of the black line that is present in the spectrum. And the third one is David Brewster, as you can see his image, and he explained that how the absorption of light take place. Okay, then Robert Busen and Gustav Kirchhoff studied the sodium spectrum and came in conclusion that every element has its unique spectrum that can be used to identify elements in the vapor phase. So a person, that is Robert Bunsen and Gustav Kirchhoff, they are the two person who studied the sodium spectrum. They are the scientists, or they are the chemist, as you can say, that they studied the sodium spectrum, and they concluded after their studies on sodium spectrum, so they conclude that every element, means whatever the element is, so they have their unique spectrum and they can be used to identify the elements in the vapor phase. Okay, Kirchhoff further explained the phenomena by stating that if a material can emit radiation, means if there is a material and if that material can emit radiation of certain wavelength, that it may also absorb radiation of that wavelength. So although Bunsen Kirchhoff took a large step in defining the technique of atomic absorption spectroscopy, it was not widely utilized as an analytical technique except in the field of astronomy due to many practical difficulties. So, Bunsen and Kirchhoff took a large step. How they have took the large step? So they defined the technique of atomic absorption spectroscopy, and it was widely utilized as the analytical technique, except in the field of astronomy. So in the field of astronomy it is not used. Why? Because there is many practical difficulties came into the path. So this is the history. Now, in the year 1953, Alan Walsh drastically improved the AAS method, that is atomic emission absorption spectroscopy. So he is the person that he just changes that how the atomic atomic absorption means he has improved the method of atomic absorption spectroscopy. So he said that atomic absorption spectroscopy to many instrument manufacturers, but to no avail. Although he had improved the method, he hadn't shown how it could be useful in many applications. So he have improved, but his improvement doesn't show. He doesn't told how it could be handled in the many applications. So in year 1957 he discovered the use of atomic absorption spectroscopy that convinced manufacturer market and the first commercial atomic absorption spectrometer. So since that time atomic absorption spectroscopy popularity has fluctuated as other analytical technique and the improvements to the method are made. So this is the history behind the whole atomic absorption spectroscopy. The history took first by the Marcus, William and David, then later by Robert Bunsen and Gustav Kirchhoff, and later on Alan Walsh was a person who have improved the AAS method. For the whole thing was placed by different scientists, and their work contributed in the discovery of AAS method. Now comes the most important topic of today's discussion, that is principle of atomic absorption spectroscopy. So this type of principle means it is heading is very important, as in the atomic absorption spectroscopy. It is based on upon the principle that free atoms in the ground state can absorb light of certain wavelength. So these are of a very specific wavelength, given the techniques excellent specificity detection limits in AAS analysis. Absorption for each element is specific, no other elements absorb this wavelength. So this atomic absorption spectroscopy, it's based on the principle that free atom in the ground state, they can absorb the light of certain wavelength. So the atoms that are present in the ground state, so they absorb the light of certain wavelength. So every specific wavelength gives the technique of the excellent specificity and detection limit. Okay, so absorption for each element in specific, no other element absorb this wavelength. Okay, so simple है कि this technique or this method or analytical method is based on the principle that free atoms that are present in the ground state, they can absorb the light of certain wavelength, and those wavelengths are very specific, which gives the technique a very excellent specificity and detection limit. Okay, So what are the basic typical application of AAS include? So they are very much important where you want to have a quantitative metal concentration in the solution. So they have a typically good detections of the quantitative metal concentration that are present in the solution. Then they have they can analysis of the lead in the paint, the lead that is present in the paint. They can have those the analysis. Then they can monitor the trace element in industrial effluent stream. So they can monitor the trace metals. So they can also have a huge demand in where the trace elements in the product or a raw material along with ICP and MS. Analysis of additives and purity in street and other metals alloy. They have a good analysis of low level contaminants. So they have a huge applications in different level. Then comes the types of atomic absorption spectroscopy. As you can see this table, so there are basically four types of atomic absorption spectroscopy. So the first one is the flame atomic absorption spectroscopy. Then it's a cold vapor. Then there is a hybrid generating. Then there is a graphite furnace. So how many types? Flame atomic absorption, cold vapor, hybrid generating, and graphite furnaces. So these are the four types of various AAS. Okay. Now comes the instrumentation of atomic absorption spectroscopy. So as you can see this diagram, this is the whole setup of atomic absorption spectroscopy. The first one is the hollow cathode lamp. Then second is one is atomizer, that is flame. Then it has a nebulizer. They have a sample solution, monochromator, filter, detector, and recorder. Now let us understand each part in detail. The first one is the radiation source. So the most common radiation source in the atomic absorption is the hollow cathode lamp, that is HCl. Okay, HCl is a hollow cathode lamp. So it contains a tungsten anode and cylindrical halo cathode made up of element of desire, which is the element that is to be determined in the sample. So if you talk about what is the common radiation source, so the most common radiation source is HCl, that is hollow cathode lamp. So this lamp consists of a tungsten anode and it has a cylindrical hollow cathode that is made up of element of desire. Means whatever element you want to made up of, they can be made to determine the sample. Then these anode and cathode, they are sealed into a glass tube. Means both the anode and cathode, they are put in a glass tube and they are sealed with inert gases like neon or argon. Okay, so when the voltage is applied, so whenever you are giving the voltage between the anode and cathode, then the ionization of the gaseous atom take place. Means the ionization of the gaseous atoms take place. So they start falling on the cathode, which made up of the metal. Okay, so this initiate the ejection of metal atoms from the cathode, which is called as sputtering. Okay, some of these sputtering atoms get into an excited state and emit radiation of suitable wavelength when they came back into the original ground state. Okay, so again I am just repeating this radiation source of atomic absorption spectroscopy. It is made up of hollow cathode lamp. Okay, so this hollow cathode lamp, it consists of tungsten anode and it has a cylindrical hollow cathode. That so this hollow cylindrical hollow cathode could be made up of the desired element, and it is basically used to determine in the sample. Okay, now this anode and cathode, they are further placed in a glass tube, and this glass tube is sealed with some inert gases like neon or argon. So whenever the voltage is applied between the cathode and anode, so ionization of gas take place. So after the ionization of gaseous atom take place, so they start falling on the cathode. Okay, so the after ionization and take place, so they start falling on the cathode, which is made up of the metal that I have already told you that of your desired wish. Okay, so this initiate the ejecting of metal from metal atoms from the cathode, which is known as sputtering. Okay, so some of the sputtered atoms get into the excited state, and they emit radiation of suitable wavelength when they came back into their original ground state. Okay, now further moves to the sample. So the sample is kept in a sample chamber which is connected to a tube or with a nebulizer. So the sample, it may be of liquid or a solid. Okay, so the solid sample is first dissolved in the solvent and then they are ionized. So if you are taking any a solid sample, so the solid sample should be dissolved in the solvent, then it is analyzed, and no gases can be used, means no gas sample can be used. Okay, the sample can be used in the form of liquid or a solid, and if you are using solid, so they should be dissolved in a solvent. Now comes the nebulizer. So the nebulizer, it is a closed chamber, and which is connected with the sample through the tube. So it has a very continuous supply of fuel and oxidant for the smooth flow of the flame. So the nebulizer also contain the inert gases which act as a carrier of the sample molecule towards the flame. So if you talk about the nebulizer, so nebulizer, they contains the inert gases, and this inert gases, they act as a carrier of the sample molecule towards the flame. So this nebulizer, it is placed in a closed chamber that is connected with the sample through a tube. Okay, so it has a very continuous supply of fuel and oxidant for the smooth flow of the flame. So if you want to have a very smooth flow of flame, so there should be a continuous supply of fuel and oxidant. That is the reason only now the flame will be smooth. Then comes the burner. So burner or the flame. So if we talk about the burner, so burner has a very continuous glowing flame that is connected to the nebulizer. So the flame is continuously glowing through a continuous flow because of the continuous fuel and oxidant. Okay, so it is one of the flame in which the atomization of sample molecule take place, that the atoms of the molecule gas from the lower energy level have to a higher energy level, then return to the ground state by emitting the radiation of a suitable wavelength. Okay, now comes the lenses. So the lens is used to converts the emitted radiation into a single path. So what is the use of lenses? So the lens is used to converge the emitted radiation into a single path. So they converge the emitted radiation into a very single path. So this is done to avoid the loss of energy from the emitted radiation. So this is done to avoid the loss of energy from the emitted radiation. This will improve the accuracy of the graph. Okay, now comes the sixth component of the instrumentation, that is known as monochromator. So if you talk about the monochromator, so the monochromator, it helps to separate the wavelength of the emitted radiation. So a monochromator is adjusted with the help of a computer software. Then comes the detector. So the detector helps to detect the emitted radiation that passed through a monochromator. A detector should be able to detect even a weak signal to produce a better accuracy. So detector, it is helps to detect the emitted radiation whenever the radiation is passed through a monochromator. So if you talk about a good detector, so it should be used to detect even a weak signal to produce a better accuracy. So detector should be of a good quality. Then comes the computer. So the computer is an integral part of the flame emission spectrometer. It helps to grow a graph of the emission spectrum of various atoms of the sample. It is done with the help of a suitable software. Okay, so that brings to the end of the lecture. Okay, now let's quickly discuss some important questions based on this topic. So first question can be asked in the interview is about what do you understand by atomic absorption spectroscopy? What are their applications? Okay, they can ask you about how is the discovery of atomic absorption spectroscopy take place, who all are the scientists behind this work. So you have to name them and have to name their contribution. They can ask you about the principle, because in every spectroscopy, whether it's a X-ray fluorescence spectroscopy, atomic absorption or atomic emission spectroscopy, whosoever spectroscopy or chromatography technique, every analytical technique have a specific principle, and the principle part is very important. So you must know the principle behind each spectroscopy. So here also is principle play a very important role, so you must be knowing about the principle. Then they can ask you about what are the types of atomic absorption spectroscopy. So basically there are four types, and one type I have explained here, that is the flame one. The flame atomic absorption spectroscopy, this whole setup is of the flame. I have already discussed about their various component, that is how the what is the radiation sources, what sample could be used, what is a nebulizer. So sometimes in examinations or interview part point of view, nebulizer is the very important topic of discussion, so you must be knowing this nebulizer. Okay, I'm just marking it an important, so you must be important. Nebulizer play a very important role, students, so you must be knowing about the nebulizer. Then they can ask you about the burner and flame, and they can ask you about what do you understand by monochromator. Okay, what is the work behind monochromator. They can ask you why lenses are used. Okay, so how the flame becomes very smooth, how the flow of fuel become very smooth. So what is the funda behind that? So you must be knowing that this fuel and oxidant act as a carrier, or act as a good source for the smooth flow of the flame. Okay, so these are certain questions that can be asked in the interview. So this is the first part. In the second part, we will going to have a detail of the process. We will going to have a detail about the application, advantages and disadvantages. So I hope you have understood the first part. If you have any queries, students, related to any of the slide or related to any of the topic, you can simply leave your queries in the comment section below. In the next lecture, I'll be answering all the queries. Thank you for watching. Please do like, share and subscribe. And at last, if you have any query, you can call on this helpline number, that is 7080833450. This is our website, that is www.itlsacademy.com. You can simply visit this website and get updated. So thank you again for watching.